Support Moof University and the production of more video tutorials by making a financial contribution or by getting yourself one of these t-shirts. Details under the Support Moof section of moofuniversity.com. The link will be in the description below. Thank you and enjoy.
Second matter law that we'll be talking about is the law of definite composition, or the law of definite proportions, also known as the law of constant composition. So who stated this law? It was this French guy named Joseph Proust. If that pronunciation is bad, I apologize. What does the law say, though? The law says that different samples of a pure chemical compound always contain the same proportion of elements by mass. So what are some key words in this? First of all, we're talking about a pure chemical compound. Okay, different samples of a pure chemical compound always contain the same proportion of elements by mass. Okay. So let's look at this as far as what does it really mean by taking a look at these examples. So if we think about water, H2O, right? H2O is 1 part hydrogen by mass and 8 parts oxygen by mass. How do I get that? Well, the atomic mass of hydrogen is 1, and the atomic mass of oxygen is 16. Okay, so here I've written its atom ratio, right? The ratio of the number of atoms they have. There are 2 hydrogen atoms for every 1 oxygen atom. Okay, so what does that mean as far as their mass ratio goes? Well, if we think about how if there are 2 hydrogens, we're going to have to multiply this number 1, right? This 1 for its atomic mass by 2. So we're going to have a mass ratio of 2 to 16, right? So that just simplifies down to 1 to 8. So that's the idea there for water. Okay, so as long as we have pure water, right, nothing's in a sample that we're other than water, this will always be true. This will always be the mass ratio, 1 to 8 as far as hydrogen to oxygen. Okay. If we have ammonia, we'll have 3 parts hydrogen by mass and 14 parts nitrogen by mass, because the atomic mass again of hydrogen is 1 and of nitrogen is 14. So 3 hydrogens would be 3 times that 1, which would be 3 here. 1 nitrogen, 14. That's our ratio there. Our mass ratio is 3 to 14, right, for hydrogen to nitrogen. So that's going to always be true for any pure sample of ammonia. Okay. For carbon dioxide, we'll have 3 parts carbon by mass per 8 parts oxygen by mass, right, for carbon dioxide. So carbon's atomic mass is 12 and oxygen's atomic mass is 16. So if we have 1 carbon and 2 oxygens, right? So 1 carbon, 1 times 12 is just going to be 1, or excuse me, 1 times 12 is going to be 12. And then 2 oxygen, so 2 times 16 is 32. So we have a ratio of 12 to 32, which of course if we just divide each of these by 4, right, we'll get 3 here and 8 here. So that's how we get that mass ratio. So as long as we have a pure sample of carbon dioxide, this ratio here will always be the case. This mass ratio will always exist. That's going to be the same for ammonia and for water. So that's basically what the law of definite composition is. It's the idea that we have specific whole number ratios, right? And they're not random ratios or proportions. As long as you have a pure chemical compound, the ratios by mass for that compound will always be the same. That's the idea behind this law. Hope that video was helpful. Thanks for watching.
Don't forget to hit that video with a like if you found it helpful or enjoyed it, and be sure to share it with anyone else who you think might find it helpful. Also, if you'd like to support the channel, follow Moof University on the different social media links, Twitter, Facebook, all that stuff, links in the description below. Thanks, and happy studying.